Hello, this is Chandrakant Chauhan and today I am going to be teaching about differential amplifiers. So this is a differential amplifier and we can see the similarities like to a inverting and non-inverting amplifier. There's a voltage V1 here on the inverting channel terminal and the input source V2 over here on the non-inverting terminal. So as we remember in an inverting terminal in an inverting amplifier there used to be a voltage source V1 over here and this V2 used to be grounded. Similarly, in a non-inverting amplifier, there used to be a V2 source and this V1 used to be grounded. So this is basically a combination of both. We have two signals going on to both inverting and non-inverting channel. So now if I want to find out if I have these two voltages, what is V out going to be? If I want to find out, we are going to use the principle of superposition. What is that? It is basically when we find out the potential at a particular point due to individual components, that is V1 at first, considering V1 V2 to be 0, and then at the second time we will consider V1 as 0 and what is the potential going to be at the output channel at the output terminal due to V2. So let's try and do that. Let's consider case 1 when V2 is equals to 0. So we have V1 over here. Let me just quickly draw it. Resistance. This R2 and this and this is basically grounded and this is our output. So let's see what is the value of output going to be. This we can clearly see this is an uh, inverting amplifier. We can clearly see it resembles that. So what is the output going to be? It is going to be minus R2 over R1 times the input voltage that we have given, that is V1. So this is the basically this is the uh, component of V output that is going to be due to the V1 input signal that we have given on the inverting terminal. Now in case 2 we consider that V1 this V1 is 0 and only V2 was applied. We are going to assume that only V2 was applied. So what is the output going to be in that case? Let me quickly draw that. This is R2, this is R1, pardon. This is R1, this is grounded, this portion, and here we have applied V2, and this is V output, and this is basically feedback we have given from the output. A particular portion of output we have given as a feedback to the non-inverting, so to the inverting channel, basically input. This is R2. So this is nothing but this resembles the non-inverting amplifier. So the output VO is going to be R2 over R1, 1 plus R2 over R1 times the input we have given V2. So basically these are the two components, this second one and this first one. Now we have to add both of these to get the net V output. That would be V1 times R2 over R1 plus plus 1 over R2 over R1, 1 plus R2 over R1 times V2. So this is going to be the net equation. But why the name differential amplifier then? What has it got to do with this result? We are going to find out right about now. So let me redraw the diagram of the amplifier and with a little bit of new component added. Uh, Series of resistances we are going to be adding over there then. This is V out minus plus. Here is the twist. We are going to be adding two resistances over here. this is R1, this is R2, this is grounded, this is same V2 that we applied earlier, this is V1, this is R1, and this is R2, our feedback resistance. So now case 1 is going to be same. If I consider V2 as grounded, then what is the component going to be? V out due to this portion. So it is going to be same R2 over R1 minus V1. This is the first case. Now second is a little interesting case over here. We have V2 applied over here, and this is kind of a circuit we have going on. We have to find the output voltage. So if we consider V1 as 0, then what should the output be? This also looks like a, basically, if V1 is 0, this also looks like a case of inverting amplifier, where this voltage we have to consider. Let's say this is V plus, right? So we have to consider V plus voltage, and everything is same. So expression is going to be case 2. Expression is going to be R2 over R1 plus 1, this thing, times V positive. So we have to just find this V positive over here. How are we going to find that? So we know the input impedance is very high for an operation amplifier. If the current goes over comes from here, it is not going to enter this portion. It will go here into the ground. So I can consider these two resistance R1 R2 are in series with a potential V2 is applied across both of them. This potential is V over here, V plus. So I have to find this potential. So the potential difference across R2 is nothing but V plus, because either this at this portion potential is 0. So we just have to find V plus. V plus is going to be just we are going to use the properties of two resistors connected in series, that is R2 over R1 plus R2 times the entire voltage that we apply, that is V2. Yes, this is V plus. So what is this expression going to be then? This is the V output because of the second input signal that we have provided. So it is R2 over R1, rather we just take the thing, times V plus. V plus is nothing but R2 over R1 plus R2 times V2. This expression gets cancelled. This is R2 over R1 times V2. This is the second expression. Now what is the net value of V output going to be? This would be R2 over R1 minus V1 plus R2 over R1 plus V1 plus V2 by principle of superposition. This would be V2 minus V1 times R2 over R1. Now we have expressed it in terms of like in this way, delta V times some factor K. So we have expressed the amplification. This can be also done like this is V output, right? So the ratio of V output over V input would be in this form only. So the amplification we have expressed in terms of the difference of the voltage. That's why the name differential amplifier. And there is one more thing, the input impedance. If we see over here, due to this channel is going to be R1. If we see it from here, V1 portion, from here the input impedance is going to be R1 plus R2. Here the input impedance was R1. From here R1 plus R2, current is going to go here. So the input impedance depends on these resistances, which is often low. So how do we increase the impedance? There's a simple way. We use buffer amplifiers for that thing. We are just going to connect this. Let's say this is V1, this is a buffer, and this is V2, this is a buffer. We are just going to attach these two on the input terminals that we have, and what it does is basically it increases the impedance to a very high value, and keeping the input signal same. The output is same as input signal. So if this is V1, here also there's going to be V1 plus the impedance has been increased to a very high value. Similarly, here is V2, here is also V2, and the impedance has been increased. So this is how we fix the lower impedance problem as well, and that is all about differential amplifiers. Thank you.